Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 6, RK Bali Navigation book, the 4th edition book. If you have any other edition book like the 5th one, the 6th or the 7th one, no problem, the questions still continue to remain the same. So let's start with question number 11. A radar has a beam width of 3 degree, a pulse of 4 microseconds. The target azimuth resolution at a range of 60 miles will be approximately what? So how to do this sum? So a radar has a beam width of 3 degrees. A radar has a beam width of 3 degree. The target azimuth resolution at a range of 60 nautical miles will be how much? So at a distance of 60 miles, okay, at a distance of 60 nautical miles, what will be the target azimuth resolution? So let's apply 1 in 60 rule formula. That is, we will have to find out this side of the triangle, this, okay, x. So now this 3 degree will get divided into two parts, 1.5 and 1.5. 1.5 here, 1.5 here. So angle equals to distance of track divided by distance gone into 60. So 1.5 degree equals to distance of track, which is your x, divided by distance gone 60 into 60. So distance of track equals to 1.5 nautical miles. So this x is 1.5 nautical miles. Okay, this is 1.5 nautical miles. So this will also be equal to 1.5 nautical miles. So the total distance 1.5 plus 1.5 is 3. Okay, so the target azimuth resolution at a range of 60 nautical miles will be 3 nautical miles. So that means there must be 3 nautical mile difference between two targets. Okay, or these two targets should be separated by 3 nautical miles. Next, what are the errors in a DGI? What are the errors in a DGI, directional gyro indicator? So first, option A, transport vendor, earth rate, heading errors, mechanical imperfection. So transport vendor, yes. Earth rate, yes. Heading errors when banking and pitching, yes. Mechanical imperfections, yes. So all the options are right. 1, 2, 3, 4 are right. While using airborne weather radar in the weather mode, the strongest returns on the screen indicate areas of high concentration of large droplets, areas of wind shear, areas of turbulence. So answer is option alpha, areas of high concentration of large water droplets. So always they use three colors. So first they start with black color, followed by green, then yellow, okay, I will write it in orange color, green, yellow, red. So black color on the screen, that means there is no return, no reflection of airborne weather radar signal. So that means the space ahead, the atmosphere ahead is clear of any water droplets. Green. Green means light returns. There are some light returns from water droplets ahead of you. Yellow, medium returns. Medium return. Red, strong returns. Strong return or heavy return. Okay, so if you see red colored dots, too many red colored dots on your airborne weather radar display, that means that this red colored dots resemble or represent area of largest concentration of water droplets. And then from this information you derive that flying into that area can be turbulent. Okay. So first, areas of high concentration of large water droplet is the primary information, and secondary information is that area may be a turbulent area to fly in. Okay, so that is what you derive from this information. Next, question 14. The operational details of aircraft are maximum takeoff weight, so and so, maximum landing weight, maximum zero fuel weight is given to you. Burn off fuel, that means strip fuel that you are going to burn 6.5 tons, 6.5 thousand kg. Reserve fuel 3.5 thousand. Operational weight of your aircraft 42,000. Calculate maximum payload that can be carried. Okay. So step 1. What is your step 1? Draw 3 columns. One for takeoff, another for landing, and the third one for zero fuel mass. In the takeoff mass column, you are going to write a value or a quantity which is the less of maximum structural takeoff mass and performance limited takeoff mass. In the landing mass column, you are going to write a value which is the lesser of maximum structural landing mass and performance limited landing mass. And to that quantity, you are going to add trip fuel. You are going to add trip fuel. In the zero fuel mass column, you are going to write zero fuel mass, whatever given in the question, plus fuel on board. Fuel on board means takeoff fuel. The fuel in the fuel tanks when aircraft is lined up with the runway ready for takeoff. So let's start. We have been given maximum takeoff weight 72,000. So I'm writing here 72. Landing weight 63,000. So I'm just writing 63 for 63,000. Trip fuel. Trip fuel is 6.5 tons. 6.5 into 1000. So that is 6,500. Okay. So 6.5, 63, that is 69.5. Zero fuel weight 60,000, 60 ton. Plus fuel on board. Now this fuel on board is nothing but your trip fuel plus reserve fuel. Reserve fuel, alternate fuel, all that fuel. So here we have been given trip fuel 6.5 thousand, reserve fuel 3.5 thousand. So that is equal to 10,000. So I'm adding it 10. 10 ton means 10,000. So that is equal to 70. Now out of these three takeoff values, 72, 69.5, 70, you're going to select that takeoff value which is the least of all. So here 69.5 is the least. So your regulated takeoff mass becomes 69.5 thousand kg or 69.5 ton. Step number 2, directly use the formula for payload. What is it? Regulated takeoff mass is made up of three components: your payload or traffic load plus dry operating mass plus fuel on board. So 69.5 equals to payload plus fuel on board is 10, dry operating mass 9.5, payload, dry operating mass. So operational weight of aircraft 42,000. Okay. Fuel on board 10. So payload will be equal to 69.5 minus 52. 69.5 minus 52 is 17.5 or 17,500 kg. So option Charlie is the correct answer. 15. For a flight from station Zulu, aircraft cruises at a TAS of 235. It goes outbound 090. Fuel on board 2,500 pounds. Fuel consumption 255 pounds per hour. And in case of one engine failure, reduced TAS and fuel consumption are 180 knots TAS. Okay, and 190 pounds per hour. Average wind component is plus 30 knots. What shall be the radius of action if one engine fails at the time of coming back. Okay. Since it involves engine failure, step 1, we will find fuel consumption outbound in terms of kilogram per nautical mile. That will be equal to fuel consumption rate divided by ground speed of your aircraft outbound. Okay. So let's say you're going from point A to point B. This is your PNR. Now going outbound, you are getting a true airspeed of 235 knots. 235 knots. The wind component is plus 30 knots. Okay. So going outbound, you're getting a wind component of plus 30. That means you're getting a tailwind. So the true airspeed of your aircraft, ground speed of your aircraft will be 235 TAS plus wind component of 30. So that is equal to 265 knots. Now fuel consumption outbound when all your engines are working is normal fuel consumption 255 pounds per hour. 255 pounds per hour. So step 1, fuel consumption outbound. That means how much fuel you will require to cover or to travel every nautical mile. The formula is fuel consumption divided by ground speed. So what is the fuel consumption outbound? It is 255 pounds per hour divided by ground speed 265 knots. 265 knots is nothing but 265 nautical miles per hour. So RR will get cancelled. We are left with pounds per nautical mile. So instead of kilograms per nautical mile, I will write here pounds per nautical mile. Concept is the same. So fuel consumption outbound equals to 255 divided by 265, which is 0.96. So you require 0.96 pounds fuel to cover 1 nautical mile. Next step, calculate fuel consumption homebound. So now returning home, you experience an engine failure. So what will happen? When you experience engine failure, automatically your true airspeed will decrease, your fuel consumption rate will decrease. So coming back home, your true airspeed is 180 knots. So let's write it here. True airspeed coming back home is 180 knots. Fuel consumption rate is 190 pounds per hour. Now coming back home, the wind component is plus 30, just like before. Coming back home, this same wind component will serve as a headwind. So your ground speed will be 180 TAS minus headwind component. So 180 minus 30, that is equal to 150 knots. So let's write this. Formula is fuel consumption homebound equals to fuel consumption rate divided by ground speed. So coming back home, your fuel consumption is 190 pound per hour and ground speed is 150 knots, 150 nautical mile per hour. 190 divided by 150 is 1.26 pounds fuel per nautical mile. So coming homebound 1.26 pounds per nautical mile. So this is your step 1. Now step 2. Step 2. Usable fuel. You have to calculate usable fuel. Usable fuel is equal to total fuel on board minus reserve fuel, because you are not going to use your reserves. Total fuel is 2500 pounds and reserves. So let's check whether we have been given reserves here. Aircraft task is given, fuel on board, fuel consumption, engine failure task, fuel consumption. What shall be the rating? Okay. So we have not been given any reserves. So that means we are going to use 2500 pounds of fuel completely. Okay, 2500. Now step 3. Step number 3. Distance to PNR equals to fuel available or fuel usable fuel divided by consumption outbound plus consumption homebound. So available fuel is 2500 pounds. Consumption outbound is 0.96, 0. Plus 1.26. So that is 2500 divided by 0.96 plus 1.26, 2.22. So 2500 divided by 2.22 is equal to 1126 nautical miles. Okay, so the closest option is option. The closest option is option A. Option A, 1122. Okay, so this is how you do this. I have solved similar questions from Oxford book, Oxford Flight Planning and Monitoring book. All these PNR questions from there I have solved and uploaded to my channel. So watch all those video lectures, your concept will be further reinforced. Next. A flight is made from one VOR, which is at 51° north, 1 degree west, local variation 8° west, to another VOR which is located at same latitude but 6° west. So that means VOR B is located to the west of VOR A. Is located to the west of VOR A. Okay. Next. Same radial is maintained throughout the flight. So you are traveling from VOR A to VOR B, maintaining the same radial throughout the flight. If drift is 7 degrees starboard and aircraft is flying a great circle path, what is the heading on departure? So easy question. So this is VOR A. This is VOR B. This is the north data. So now both locations are at same latitude. Both locations are at same latitude. That means in order to travel from VOR A to VOR B, you will have to travel radial, or you will have to follow a radial. You will have to follow a radial of, you will have to travel a radial of 0, correction. You will have to travel a radial 270 from VOR A. Okay, you will have to follow a radial of 270 from VOR A. You will continue traveling this or following this radial 270 outbound, and somewhere mid course, if you have to change to the next VOR, let's say somewhere over here, what you will do, you will change your aircraft VOR OBS setting. What will you do? For example, I will draw the VOR. Here you will set the frequency of VOR A OBS 270 from indication. Once you are required to change to the new VOR, to the next VOR, what will you do in your OBS setting? You will change the frequency of your old VOR and tune into the next VOR, new frequency of VOR station Bravo, the next VOR station. You will change your OBS setting. So 270 will remain the same, and once you tune into the next VOR station, automatically from will become 2. Now because you are flying 270 radial outbound from VOR A, over here when you change to the next VOR station, you will be flying inbound towards that VOR station and inbound on radial 090. The same radial will be radial 090. This is radial 270 of VOR A. This will be radial 090 of VOR B. So you will be flying radial 090 inbound towards that VOR B. So the correct procedure will be to set your OBS 270. Don't change it. Same as this. Automatically once you tune to this VOR frequency, it will become 2 indication. Okay, from will become 2. Now you are getting a drift. So that means they have asked what is the heading on departure at the start of your flight. So at the start of your flight, you are flying a track 270 outbound, correct? You are flying a track 270 outbound. Now we all know if you are getting a starboard drift, in case of starboard drift, the heading is less than track. So what is the starboard drift? 7 degrees. Track is 270. So heading should be less than 270. So the heading that your aircraft should follow will be 270 minus 7, that is 263 degrees. 263 degrees. That means you will be flying radial 270, but your aircraft will be oriented on a heading 263. So a little bit like this. 263. Okay. 263. So the yeah, 263. Now again, next the answer is not over yet. We have to check the variation. Now this 263 degree is your true direction. This radial 270 that we have considered, although all radials are in magnetic, in this question they have specifically mentioned variation. That means, so all the values that we have solved so far are with respect to true north. Okay, so heading is 263 true. Now let's convert this into magnetic heading. So heading is true. Now variation, there are two variations given to you. Variation at position alpha, variation at position bravo. So since you are calculating your heading at position alpha, you will use the variation existing at position alpha, VOR A. So over there the variation is 8 degree west. Variation is 8 degree west. So variation west, magnetic is west. So magnetic heading will be true heading plus variation. So that is equal to 263 true heading plus a variation of 8 degree. So that is equal to 271 magnetic. 271 magnetic. Okay. So correct answer is option Charlie. You will have to maintain a magnetic heading of 271 when you start your flight from position A. Next. Two aircraft start from the same position at the equator. One aircraft flies on track 000, that is north direction, for distance of 5,400 nautical miles, while aircraft B flies on a track easterly, distance 2,500 nautical miles. On reaching their destinations, the bearing of A from B will be what? So position at the equator. Aircraft A flies on a track of 00, that is northerly direction, for 5,400 miles, whilst the second aircraft flies easterly distance 2500 miles. On reaching the destinations, the bearing of A, that is the first aircraft from second aircraft, will be what? So let's draw the Earth. Let's say this is your Earth and this is your equator, correct? 0 degree north south equator. So aircraft A starts from equator and flies a north direction for a total distance of 5,400 nautical miles. So when you fly along a meridian, north or south, you're actually flying a great circle track. So what is the great circle distance? D lat into 60. So D lat will be great circle distance 5,400 miles divided by 60, which is equal to 90 degree. So that means the difference between two latitudes is 90 degree. The initial latitude is equator and the final latitude will be 90 degree. That means 90 degree north pole. That means your aircraft A, the first aircraft, aircraft number A is aircraft number A. The departure is equator, the destination of which is north pole. Now aircraft number B, it travels in the direction of east for a total distance of 2500 nautical miles. 2500 nautical miles. So that means it is following a rumline distance. Okay, you fly a rumline track between two meridians along the same parallel of latitude. So rumline distance equals to d long in minutes into cos lat. So 2500 nautical miles divided by cos latitude is 0 degree equator d long. So that is 2500 minutes or 2500 minutes divided by 60, that is 41 degree 40 minutes east. So your new position is 41 degree 40 minutes east. Now we have to find out the bearing of aircraft A, which is at North Pole, from this position B, aircraft B, which is at longitude 41 degree 40 minutes east equator. So now since our aircraft A is at North Pole, okay, so the bearing from any position on the earth towards the North Pole is only one, that is 360 degree direction. Bearing is going to be 000 degree. Why? Because once you reach the North Pole, so from any other location on the earth, from the equator, if you want to go to the North Pole, you will have to fly one fixed heading, that is 360 degree heading or 000 degree heading. Okay, that's right. So any direction you go from the North Pole, you will have to follow a heading of 360. From any position on the earth, you will have to follow a heading of 360 if you want to go to North Pole. So bearing of A at North Pole with respect to B is 360 or 000 degree. Option A. Very simple and practical question. Next. On a Mercator chart, radio bearings are plotted after correcting great circle radio bearings into rumline by conversion angle directly as great circle bearing, rumline bearing after applying convergency angle. So on a Mercator chart, radio bearings are plotted after converting or correcting great circle bearings into rumline bearings by applying conversion angle. Question 19. A ground feature appears 30 degree to the left of the center line of the cathode ray tube of an airborne weather radar. If the heading of aircraft is 355 degree magnetic and variation is 15 degree east, the true bearing of aircraft from the feature is what? So let's say this is your airborne weather radar screen. This is the true heading of your aircraft. This is the true heading of your aircraft. And the island, this ground feature is 30 degree to the left of your heading. So 30 degree to the left of your heading. So somewhere here. 30 degree to the left hand side. Okay. We have to find out true bearing of aircraft from the feature. So first so heading magnetic given to us is 355. Variation is 15 degree east. True heading is variation east, magnetic will be least. So true heading will be magnetic heading plus variation. That is 355 plus 15. That is equal to 010 degrees. That is your true heading. Next, the true bearing of aircraft from the feature. So Q U J is equal to your true heading plus relative bearing. QUJ is nothing but true bearing of aircraft, true bearing from aircraft or true bearing towards the island. So from aircraft, if you want to go to the island, you will have to follow a particular bearing towards that island. That is your QUJ, true bearing to the station or to the island. So QUJ we will first find out. So that is heading is 010. Relative bearing is minus 30 degree because it is to the left hand side. So 010 minus 30 is minus 20 degree. That is equal to 340 degree. So QUJ is equal to 340 degree. That is from aircraft to the island. And now we have to find out of aircraft from the feature. So we have to find out QTE. QTE, the reciprocal of QUJ. So QUJ is aircraft to the island. QTE is from island to the aircraft. So that will be equal to 340 minus 180, which is equal to 160. 160. So option C is the correct answer. So that for that you will have to read the question carefully. True bearing of aircraft from the ground feature they have asked. So we have calculated QTE. First QUJ, then QTE. Aircraft is over position 55 degree 33 minutes north, 60 degree 15 minutes west. VOR position is 53 degree north, that means to the south of your aircraft, and same longitude but to the south of your aircraft position. Variation at aircraft is 31 degree west, variation at VOR is 28 degree west. What is the radial from VOR? So what radial your aircraft is situated on? So let's say this is your VOR. This is your VOR station. This is the north datum. Aircraft is directly to the north of this VOR station. Okay. The longitude is 60 degree 15 minutes west. Latitudes are aircraft latitude 55 degree 31 minutes north, 33 minutes north, and VOR is 53 degree 3 minutes north. That means VOR is to the south of aircraft. So finally aircraft is located on radial 360 from the VOR station. So this radial 360 is with respect to true north. We will have to convert this radial into magnetic. How will you do that? Apply variation at VOR station. Apply variation at the VOR station. They have given us two variations, one at aircraft, another at VOR station. So in problems involving VOR, apply variation at VOR. So variation at VOR is 28 degree west. Pay attention, 28 degree west. So radial will be, magnetic radial will be, variation west, magnetic is best. So magnetic radial will be true radial plus variation. True radial is 360 plus 28, that is 0 to 8. So aircraft is located on radial 0 to 8 from the VOR station, option C. So this concludes the lecture. I hope you have understood all the 10 questions I answered in this video lecture. If you have any doubt, questions, query, let me know in the comment box of this video lecture. Practice these questions again many times without looking for any answer explanation. Do it on your own. I request you all to share this video lecture with your friends who are also preparing for the exam, and hit the like button if you have liked this video lecture. Best of luck.